Friends, now we have one more problem on graphical method to solve the given LPP. The given LPP is objective function is to maximize z is equal to 3x1 plus 4x2 subjected to the various constraints here x1 comma x2 greater than or equal to 0 here. So convert the inequality constraints into equality equations. So we'll have removing the inequality constraints made everything equal sign here. So we'll have four equations here. So in each equation either we'll take x1 as 0 or x2 as 0 to get the other variable here. So if you take the first equation 5x1 plus 4x2 is equal to 200. If you make x1 0, x2 becomes 50. If you make x2 0, x1 becomes 40. So that is what written here. So x1 value is 40 here and x2 value is 50 here. The other variable is made 0. Similarly, second equation 3x1 plus 4x2 is equal to 100. If you take x1 as 0, x2 becomes 25. If you make x2 0, x1 becomes 100 by 3. So that is what here shown. The other variable made 0. So x1 value is 100 by 3, x2 value is 25. If you take the third equation, if you make x1 0, x2 becomes 20. So that is what shown here. If you take x2 0, x1 becomes 10. So that is shown here. So then in the fourth equation, if you make x1 0, x2 becomes 30. So that is what shown here. If you make x2 0, x1 becomes 50. So x1 is 50, x2 is 30. So for which four different lines will be drawn. So the first line is having the coordinates 40 and 50. So 40 and 50. So one line is drawn. So here the constraints are all, so the first two constraints are less than or equal to. So for this line, the first equation, the area is less than or equal to. So I have to consider the area below this line. I cannot go beyond this. So now the next line, so that is 3x1 plus 4x2 is equal to this. So I have the coordinates 100 by 3 comma 25. So 100 by 3 on x-axis, 100 by 3. So that is 33.3 on x-axis and x2 is 25. So x2 is 25. So that is this. Right. So then we'll have then 5x1 plus 4x2. So that is that is over. Then the next equation 8x1 plus 4x2. So then we'll have the coordinates 10 comma 20. So for that one line is drawn here. So 10 comma 20. Okay, so 10 comma 20 for which you see the constraint and take the area accordingly. If it is less than or equal to, take the area below the line. If it is greater than or equal to, take the area above this line. So for all the four lines, you just take the area whether if it is less than or equal to, take the area below the line. If it is greater than or equal to, take the area above that given line. So finally the feasible region should be chosen such a way that the area chosen should satisfy all the four constraints. So this is the feasible region. So take all the corner points there. So we are getting 5 different corner points with these coordinates, substituting the x and that is the two coordinates, so that is x1 and x2 in the objective function, that is maximizing z. So you are getting 5 different values of z here. So out of this you have to go for the maximum value of z. So that is Here you are getting the maximizing value of z is now that is 138.4. So with the coordinates, so that is 30.8 comma 11.5. So x1 value is this and x2 value is this, and the maximum value of z is this. Thank you.